the same case. So far, I have 3 people saying 5 and 4. So, and I would agree. In my mind, excellent and very good health are closer together in my subjective interpretation of health than any other gap. And I'd probably say the biggest gap in my mind is between 3 and 2, good and fair. Well, if you believe the gaps are not equally spaced, is it fair to calculate an average? Is it fair to take a person who says their health is excellent, a 5, another person who says their health is good, a 3, and try to combine those 2 people's answers together to describe what's happening on average? Because if you average the number 5 with the number 3, you'll end up with the number 4. And the number 4 means very good. So you should only be doing that if you think the state of health, very good, is halfway between the distance between good health and excellent health. Otherwise, you shouldn't be doing this calculation. We do it all the time in these quality of life measurements. We essentially assume that the numbers we're assigning to different stages of health are equally distant apart, and the integers 1, 2, 3, 4, and 5 represent that equally distant space. More importantly, most quality of life instruments, health status instruments, have multiple questions. You'll ask people, for example, if you're measuring their physical function, can you carry a bag of grocery up 3 flights of stairs without feeling winded? Can you walk easily for a mile without feeling winded, or something like that? There might be a series of questions that you ask a person about whether they can do the various tasks. And the responses that people could give you is that I can do it without any difficulty, I can do it with a little bit of difficulty, maybe a moderate amount of difficulty. But then what you do is you take the answers to those individual questions and you add them together. Give the person a single number to represent his physical activity, his physical function. But to do that averaging, you have to be assuming that the numbers not only reflect order, but also reflect distance. Because averaging, or summing answers together, assume that those numbers are representing the states that are equally spaced apart. So going back to that table, for ordinal measurements, something like quality of life, if the numbers only reflect distance and not order, you should not be creating averages. You should only either be reporting the proportion of people who said their health was excellent, or, as we did before, lining people up and calculating percentiles like medians. Only when you have a continuous measurement, where the numbers reflect both order and distance, things like age, blood pressure, body mass index, and maybe quality of life, depending on how the instrument is developed, only then should you be able to calculate averages. So the way you measure an outcome in epidemiology depends on the scale of the instrument you're measuring, whether it's nominal, whether it's ordinal, or whether it's continuous. And you'll do things different ways depending on the characteristics of that particular scale. So going back to that question about your health being excellent, very good, good, fair, poor, this is one of the 36 questions. They're in a well-known instrument known as the SF-36. SF-36 stands for a short form instrument. That's what the SF stands for. The 36 means it has 36 questions. It's designed by very intelligent people to measure 2 summary scales, your physical health and your mental health. It measures, I think, 6 or 7 or 8 different dimensions of health. And this is one of the questions in that instrument. How do you rate your health? Excellent, very good, good, fair, poor. But the creators of this instrument, in their minds, believe that the distance between those categories was not constant. So in the SF-36, that particular question is used in calculations to calculate summary scores. But the numbers 1, 2, 3, 4, and 5 are not the numbers that are assigned to those different states when the calculations are actually being done. What happens is they count a person whose health is excellent as receiving 5 points.
Fred,
A person whose health is
I think
poor
your
is receiving
microphone
4
has stalled.
points. But fair gives you 2 points. Good doesn't give you 3 points, it gives you 3.4 points. Numbers 1, 2, 3.4, 4.4, and 5, in their mind, reflect where the locations of those 5 different states of health fall on some spectrum of health. And notice the distance between excellent and very good is represented by 2 integers, whose gap, 5 versus 4.4, a gap of 0.6, is much narrower compared to the gap between good health and fair health, where the gap is 1.4. So here's an example where an ordinal scale was transformed into a continuous scale so it could be used in calculations by using numbers, at least in these investigators' minds, that not only reflect order, but also reflect distance. And one other last word about averages before we move along. This is a quote I found out, that averages are used all the time, but they may or may not be a good measure of a central tendency. And the quote was that if you had a person whose one foot is embedded in a bucket of ice and the other foot is in a hot stove, on average, he might be fine, although part of his body is burning up and the other part of his body is freezing. So averaging makes a lot of sense when you're averaging similar values together. It doesn't make a whole lot of sense when you have very extreme values, because maybe the average you come up with, taking these extreme numbers into account, might be a number that's different from most of the numbers you have in this averaging calculation. And to show you that with a very simple example, let's suppose we were trying to describe the lengths of stay of 5 people in a hospital. And the first example, by the first row here, let's suppose one person stayed in the hospital 1 day, another person 2 days, another person 3 days, another person 4 days, another person 5 days. And I asked you to come up with a single number that describes the distributions of those 5 lengths of stays. And you say, I'm going to calculate an average. Most of you would take these 5 numbers, add them together, 1 plus 2 plus 3 plus 4 plus 5, that ends up to be, 3 plus 6, that's 15. You divide by the number of people. 15 divided by 5 gives you the average of 3. That's what we call the arithmetic mean. Maybe another person would say, I don't want to calculate an arithmetic mean. What I'm going to do is line the people up against the wall by their lengths of stay, find the middle person in that line, and the middle person would be the person who has a length of stay of 3 days, and report that median as 3. I add another column here called the geometric mean, and I'll talk about that in a minute. But I really want to focus on this notion of arithmetic mean or averaging. What happens if I have the same 5 people? The 5th person doesn't stay in the hospital 5 days, stays in the hospital 10 days. I calculate the arithmetic mean. It's now increased from 3 days now to be 4 days. The median is staying the same. That one extra atypical value, changing the person's length of stay from 5 days to 10 days, has affected the value for that average, changed it from 3 to 4. If it was not 10 but 20 days for that 5th person, the average becomes 6. If it was 30, the average becomes 8. You can see that averages, means, arithmetic means, are influenced a lot by these extreme values. Therefore, an arithmetic mean might not be a good measure to describe an outcome, continuous outcome, that has a few outliers. Maybe a median would be the same, because notice the median doesn't change that much. Or maybe the geometric mean, I'll talk about that in a second, would be better than the arithmetic mean because it's not changing that much. It's staying around 3 days. It's staying similar to the median. But let me give you another more realistic example. This is an example of output from SAS. I looked at 958 people who were hospitalized at the hospital where I'm located, undergoing a surgical procedure where they remove part or the entire colon of a person, a colectomy. And what we have here is a number of descriptive statistics that describe what happened or describes those 958 length of stays. And I put in bold the mean length of stay was 7.9 days. About the average length of stay using the arithmetic mean was about 8 days. The median, if I go on to the next thing. Oops. On slide 2 far. Here are some other statistics describing the percentiles. The median length of stay was 7 days, meaning if I took those 958 people, line them up against the wall by their length of stay, so the first person in line was the person who had the shortest length of stay. That actually was